Alright, next example. A 2,000 kilogram car driving at 20 meters per second on ice rear ends a 1,000 kilogram compact car driving 15 meters per second in the same direction. The two cars lock together. What is the shared speed immediately after their collision? Now you might want to jump to energy conservation, but as we're going to learn later, that's not really appropriate here. Whenever two objects lock together, so just like the bowling ball and the soccer ball and the bucket in the last problem, whenever two objects move together, hold on, let me make a note here. Whenever two objects move together, that's called an inelastic collision. An elastic collision would be if they bounced off to each other. If they stick together, so anytime two objects stick together, that is an inelastic collision. You need to make a note of that. Alright, so if two objects move together, they stick together, that's called an inelastic. I don't know why there's a... That's weird. Hold on a second. There you go, correct that typo. That's an inelastic collision. Objects stick together. And the quantity, potential energy plus kinetic energy, is not conserved. That's because you have sound, so if two cars crash together and stick together, there's that crunching of the metal. There's what's called deformation, so the objects might change shape, and that takes energy to cause that. The objects might heat up, they might emit light, all kinds of things could happen. But anytime objects stick together, the energy of the system of the two objects is not conserved. Now, energy overall is conserved, so whatever energy you had, it became something else. But that amount PE plus KE is actually not conserved whenever objects stick together. So if you have an inelastic collision, objects stick together, you must use momentum conservation. So must use PI equals PF. Alright, so I told you when you work these to do first a part that you don't even think about, PI equals PF, and then give a momentum at the beginning and end for both objects, so M1 V1 I plus M2 V2 I equals M1 V1 F plus M2 V2 F. Okay? Memorize that right now, right this second. M1 V1 I plus M2 V2 I equals M1 V1 F plus M2 V2 F. And you will use that anytime you have a collision problem. Just use that. Just know that's going to happen. Anytime there's a collision, use this equation. M1 V1I plus M2 V2I equals M1 V1F plus M2 V2F. Momentum at the beginning equals momentum at the end. Okay, now in inelastic collisions, if objects stick together, so if the object is sticking together, the velocity at the end is the same, just like with the bucket, so that was also an inelastic collision. So we can, over here, just call that the final velocity since it's the same for both of them, and factor out that VF. And now we can see maybe if there's something we can eliminate from the beginning. 2,000 kilogram car driving at 20 meters per second, so that's M1 V1I. And a 15 kilogram car driving 15 meters per second in the same direction. So we might need to declare a coordinate system here. So it does say they're both driving in the same direction, so let's just call to the right positive. So any number that's positive will be to the right. And they're both driving in the same direction. Okay, so we can't eliminate anything from this side of the equation. None of their velocities are 0. M2 V2I. We are finding the shared speed immediately after the collision, so that's VF. So let's go ahead and get VF by itself. M1 plus M2. M1 plus M2. And then we have M1 V1 I plus M2 V2 I over M1 plus M2 equals VF. And now I'm going to move this over here just for space. Let's go ahead and substitute in what we know. We know the mass of car 1 is 2,000 kilograms, driving at 20 meters per second. plus the mass of car 2, 1,000 kilograms, going at 15 meters per second, over total mass 2,000 kilograms plus 1,500 kilograms. And let's see what I get when I do that. As I was starting to do that, I realized I made a mistake here. The mass of that second car is 1,000 kilograms, not 1,500 kilograms. Doesn't make any other difference because I got it right up here. But as I was typing that in the calculator, I realized that's a 1,000 kilogram car, not a 1,500 kilogram car. All right, and I get VF is equal to 18.3 meters per second. And that's positive, so my car is moving to the right. All right. And that's how you solve inelastic collisions. We'll talk more about elastic and inelastic as it goes along. That was more a preview just thrown in since it seemed appropriate with this particular example. All right, in this post there should be a couple poll questions that I hopefully got to explain to you how those work today. If not, just answer them, and they should be able to answer them on any device: computer, iPod, iPhone, Kindle, whatever. And see you tomorrow in class.